Alright guys, today we're going to be talking about applying radical transformations. So this goes way back to linear transformations. That's why we spend so much time going over linear transformations, because once you have a strong base in linear transformations, it really does carry over into everything else when you're going over, let's say, quadratic transformations, or even radical transformations. So if you have a strong base in linear transformations, right, this will seem fairly easy to you, okay? But if not, okay, I made a little cheat sheet that you can use, okay, when transforming these radical functions. So again, you may not need this if you have a strong base in linear transformations. I highly suggest you go back and look at some of those videos I created on linear transformations, because it really does help you in the end. Okay, but again, we can always use this cheat sheet right here, so let's just kind of go through it, and then we'll start going over the problems. All right, so we have our radical function here, and each little letter here represents a certain part, so let's go through it. So A here, okay, is going to account for our vertical stretch or compression. All right, so in other words, if A is greater than 1, okay, it's going to be a vertical stretch. Right? If A is between 0 and 1, it's going to be a vertical compression. All right. Moving on, we're looking at this 1 over b, all right? So if b is greater than 1, okay, it's going to be a horizontal stretch, all right? If b is between 0 and 1, it's going to be a horizontal compression, okay? All right, moving on, this h value is going to be for our horizontal shift. Now remember, that's always opposite of what you think, okay? So if you see it as, let's just say that was -3, all right, you're not actually shifting it to the left 3, it's actually going to the right 3, okay? So just keep that in mind. And k right here is going to be our vertical shift. And notice how our k value is not underneath the radical, that's important, okay? So the k is just our vertical shift, either up or down. All right, so let's go over some examples here. So we'll start out doing some easy ones, and we'll kind of work our way up. So we have the following. We have g of x equals, and we'll have the square root of x minus 2. Okay, so what we want to do here is describe the transformation that took place here. Well, what is our parent function when we're talking about square roots here? Because that's what we're dealing with. Okay, so what is going to be our parent function of a square root? Well, that's simply just going to be, right, f of x. Right, this is our parent function, and if you really wanted to, right, you could go ahead and graph this. So we can do that real quick. We'll do it for this problem only. All right, so we'll graph our parent function on here. So the square root of x will start at 0, 0, and then we'll go to 1, 2, 3, 4, 1, 2. We'll be at right here. So this is 0, 0. This will be 4, 2. Right, and we're going to have something that looks like that. Okay, that's our parent function. You want to go ahead and label it square root of x. Okay, so what is going to be the transformation that took place here? Well, again, if you have a strong base in linear transformations, this is very similar, right? This is going to be a vertical shift. Again, you can use your key over here, because this is my k value, right? So it got shifted down too. So what we can say here is shift down, shift down 2. And if you really wanted to, you could go ahead and graph this on the same graph so you can compare the two. So if this is 0, 0 and it's being shifted down 2, I'll have a new point at 0, -2, right? Same thing here. If this is 4, 2, I'll have a new point at 4, 0, right? And there it is. And again, you can go ahead and label it as g of x. Okay? And that would be it. So that was the transformation that took place on this particular problem. All right, fairly easy to recognize. All right, just being shifted down too. All right, let's try another example here. So moving on. And we won't graph, okay, the others just for the sake of this video. Okay, you get the point. We're comparing it to the parent function. So we have g of x equal to, and we're going to have 3 times the square root of x. And if you want to go ahead and write down your parent function just so you can have more of a visual, that's fine as well. Okay, so what is the transformation that took place here? Well, again, use your key here. Notice that that's going to be my A value, so it's either going to be a vertical stretch or compression. So if A is greater than 1, remember what I said, it's going to be a vertical stretch. So this is going to be a vertical stretch by a factor of 3. So vertical stretch by a factor of 3. Okay? So the vertical stretch by a factor of 3, and that's it. Alright, let's move on. So a little more in depth now. So we'll do g of x equals 2 times, and we'll have x plus 3. Okay, so let's go ahead and describe the transformations that took place. So here is our parent function. Okay, so there's multiple transformations here. Let's go through the horizontal shift first. So I have plus 3 here, so is that going to the right or is that going to the left? Remember, it's always opposite of what you think here, right? It's plus 3, so we're actually going to the left, right? So we're going to say here, shift horizontal left 3, okay? We also have another transformation. Again, I have an A value that's either going to be a vertical stretch or compression. Well, in this case, A is greater than 1, so it is a vertical stretch, right? So vertical stretch by a factor of 2. Okay, so we had multiple transformations in that particular problem. Okay, let's try another one. So we'll have g of x equal to the square root of negative x minus 2. Okay, so let's go ahead and do what we know first. If we have not talked about this yet, right, this negative that's not listed here. So let's do what we know first. We know this is going to be a vertical shift, right? So it's going to be a vertical, so this is another color, vertical shift. Down 2, so a vertical shift down 2. Okay, and here, go back to your linear transformations. This is going to be a reflection. It's either going to be a reflection across the x or y axis. Okay, so remember, going back to linear transformations, if you want to reflect something across the y-axis, you make the x negative. And if you want to reflect something across the x-axis, you make the y negative. Well, in this case, our x is negative, so that must mean that this is a reflection across the y-axis. So reflection across, okay, y-axis, okay? And this problem is now complete. All right, let's do one more example and that will be it. So we'll have g of x equal to negative 3 times the square root of x and then minus 1. Okay, so what we want to do here is first talk about this negative, all right, because again, it's not listed in here. But again, if you go back to your linear transformations, all right, you may be able to recall what this means. And we just talked about it in the last example, right? This is going to be a reflection. So what did we do here? What I want to do is, let me write out the parent function. So f of x equals the square root of x. Okay, and let's think about this. If I want to reflect this across the x-axis, I'm going to make the y, or f of x, right, negative here. So let's go ahead and do that. Okay, so this would be a reflection across the x-axis. But notice I can't leave that negative, right? So I'm going to have to divide both sides by negative. And our final answer here will be the following. Okay, notice how we have a negative out in front. That means a reflection across the x-axis, right? We just went through it. So when you see a negative out in the front like this, that's telling you that, oh, this is going to be a reflection across the x-axis, right? So that's one of the transformations that took place. So knowing that, let's go ahead and list that down. So one transformation here is going to be reflection across x-axis, right? Moving on, now we already took care of this negative, so let's cover it up. We have a 3 out in front, so that's going to be our A value, right? So it's 3, it's either going to be a vertical stretch or compression. Well, remember, that's our A value, and if it's greater than 1, it's going to be a vertical stretch. So we're going to say here a vertical stretch by a factor of 3. Okay? And now we just have this, which is an obvious vertical shift, right? It's not underneath the radical, it's outside, it's a vertical shift. So vertical shift this will be down 1, so a vertical shift down 1. All right, and that is it. So that is how you go about applying radical transformations.